welcome at Azure Community Day. Thank you for being here. We're live from the Netherlands, here in a beautiful studio in Utrecht. And I have a new guest here, and that's Eduard. And I was listening to the previous talk, and that was continuously about, but Bart, I have multiple environments, and I was thinking of your talk to make the joke, but Eduard, I have multiple multiple cage clusters. But no, thank you for being here.
Yeah, no problem. I like it.
Yeah, I'm so happy to have you. And the topic that you're going to talk about is about actual doing containers, doing Kubernetes, but made easy.
Yep. I
and
don't know
simple.
Kubernetes.
Well, I think that a lot of people don't really know Kubernetes.
Exactly. That's my point.
Yeah. Would you argue that people would not all need Kubernetes?
Well, first of all, the entire container technology the question is using containers mandatory or not? And the answer is always, it depends. Because there are a lot of great services available in Azure. So why should you use containers anyway? But if you go for a container technology, then the question is, do I need Kubernetes, yes or no? And basically for production environment, most of the times the answer is yes. But Kubernetes is very complicated, and not everyone is interested in learning that technology and having all the skills to control everything that you need to provision and maintain a Kubernetes cluster. And there's a fairly new service in Azure called Container Apps. That's what my session is all about. And in that session, I explain a way easier way of running Kubernetes under the hood, but don't have to learn all the nitty-gritty, complicated switches and knobs that you can twist in Kubernetes.
I'm delighted. Can't wait to hear more and learn more about that. So I'm not going to ask you all the questions that you're probably going to handle in your session. So yeah, take place.
Thank you.
And good luck with your session. Like always, if you have any questions, you can leverage the chat that is conveniently at the left or right side of your screen somewhere. It's with all the lines where you can type. And without further ado, here's Eduard telling us more about container apps. Take it away.
Yeah, thank you. First of all, I would like to notice that again we're in a virtual conference, but what you don't see is that in the background there's a lot of people working to get this conference up and running and doing a lot of effort. So please use the chat and throw a word of thank you in the chat. The organizers are reading along, and that will make them smile. And with that, let's go to the container part of my presentation. And my presentation is called Kubernetes Made Easy because I think that Kubernetes is fairly complicated, as I already discussed with Susanne. And I want to make Kubernetes easier for more people to control and to use as a service in Azure. So the agenda for today is, first of all, I'm going to explain a fairly new service called Azure Container Apps. What Azure Container Apps is, how environments work, and how you can use it to accept HTTP traffic for your services, or maybe different traffic. And there are a lot of tools that you can use in Container Apps. And so I'm going to walk through all these technologies throughout my presentation, but I'm also going to demo how I get a certain environment done from the moment that I start developing the service all the way up until it's deployed in the cloud environment. So now a little bit about me. My name is Eduard Keilholz. I'm from the Netherlands, and from the Netherlands, I'm a cloud solution architect at 4.net. And everything is out there. So please, if you have any questions and you don't feel comfortable asking those questions in the chat or whatever, then please notice all my handles are on the bottom right of the shared screen. On the bottom left of the shared screen, please contact me, ask your question if you like. So with that, running containers in Azure. Now, and you should see a container as a, if you compare it to a physical container, as a sea container that you see on the boats, then you can compare that with a container, with a software container. So you have this container, not actually physical, but there's a container and you put your software inside it. And the nice thing of this container is that as soon as you plug the container in, it will and it operates, you can plug it out, bring it anywhere, and then plug it in again, and it will still work. So it brings you the ability to move containers to certain different environments, plug them in, and if the container is correct, it will still work. So in theory, if you don't like Azure, you can go to AWS. So plug out your container, move to AWS, plug it in, and it will work. But not all the times, by the way, because there's you probably have some integration in your container left and right that you need to take care of when you bring your container from one environment to another. So running containers in Azure, there are a couple of flavors that you can use in Azure to run your containers. And you see three of them, the container instances and web apps all the way on the left. And all the way on the right, you see AKS. Now the difference is with container instances and web apps, they are fairly simple because you can just bring your container to that service, tell the service to run your container, and it will run your container. But that's about it. You have not too much control over your container. Scaling is fairly difficult. And all the way on the right, you see AKS, which is Azure Kubernetes Service. And as we already mentioned, this Kubernetes is very complicated. You have a lot of knobs to dial, and there are a lot of things to control. And you have to know what you're doing to get that cluster up and running, and you have to maintain it to keep it up and running. Now, as you see, there's a gap in the middle, and this is where Container Apps steps in. So Container Apps sits somewhere in the middle because it's still fairly simple to control and fairly simple to provision. But under the hood, you do run Kubernetes. So you do take advantage of the Kubernetes cluster and all the things that comes with Kubernetes, but you don't have to have all the knowledge of the Kubernetes cluster to control it, because there's now a new abstraction layer called Container Apps that makes this controlling this environment fairly easy. Now, I would like to go and encourage you to follow this URL. It's bit.ly and then Virtual Azure Community Day 23. This is the year, obviously, because this link will bring you to a service that I created. And with this service, I would like to monitor your current experience with containers. And it is this environment. And when you follow this URL, you will end up on this page, and it will ask you a question. Have you used containers before? And there are 5 different kinds of answers. One is nope. The other one is a local machine. Yes, I used containers in the cloud. I run containers in production, or I am a Kubernetes guru. So I will go ahead and go for the production vote. And hopefully, yeah. I see already votes coming in. I see some local machine votes, and I see the majority run containers in production. And there are some cloud options coming in. All right. I just want to get a little to get to know my audience a little bit. All right. I see some votes coming in. Now I have the majority says, okay, I did some containers in ooh, now we're switching. Okay, so nobody says no, I didn't do any containers, and nobody says, okay, I am a Kubernetes guru. Everyone is somewhere in the middle, which is exactly what I'm looking for. Now I have a different question. If you used containers before, so if I'm correct, your screen will now change with the different questions. If you used containers before, then what technology did you use to run those containers? And that is mostly for this question targets Azure. So it's non-app fabric, web apps, container instances, AKS, or a different service. And I see AKS and container instances. Only 2 votes came in, so we will wait just for a couple of minutes, maybe seconds. All right, it stays the same. So the answers on the technologies are AKS and container instances. Oh, and I see a lot more flavors here. Other and none. Okay. Nice. Okay, so now we know that there are people working with containers. There are not too many people working with containers in cloud environments, and if they do, they mostly use container instances, AKS, or a different service. All right, nice to know. Keep this demo in mind, and I will continue the presentation. So now there's this new service called Container Apps. Now, what is a container app? Again, a container app is a way of controlling Kubernetes under the hood. And a container app relies on a container app environment, which I will tell about in a bit. So when should you use container apps? You can use container apps when you want to deploy API endpoints, hosting background processes and applications, handling event-driven processes, and running microservices. And especially the last 2 bullet points, I think that's where container apps start to shine. Because if you have microservices running in a cloud environment, you always have the challenge of having the services to communicate with each other. So you need some kind of messaging system. So then you go for a service bus or event grid to make sure that the services can communicate with each other. Now, container apps comes with Dapr, and Dapr is a sidecar mechanism that you can leverage to take that stress away. For example, if you want microservices to communicate with each other, you can use Dapr to immediately make a call to a different service in your microservices environment without having to have an additional service. I will show Dapr in a bit. Now, I also mentioned a container app environment. Now, the container app environment is an environment that lives around all your container apps. So this environment ties all the bits together. And when should you create a container app environment? Well, there are a couple of things that you need to keep in mind because in theory, if you have multiple container apps, it is possible to create a container app environment for each and every container app. But probably the container apps have some kind of cohesion that in the end will create your entire application. And if that is the case, then you want these container apps to live in the same environment, because then they are visible, for example, through Dapr. So if you want to communicate with Dapr from one service to another service, then both these services need to live as a container app in the same environment. So when we make this a little bit more visible, the dark blue area around all the container apps is the container app environment in this case, and there are 2 container apps that live in that container app environment. And a container app can have 1 or more revisions active at a time. And in a revision, you have replicas, which you can use for scaling. So if some service is under pressure because there's a lot of traffic, for example, it can scale out, make more replicas, and a replica will run 1 or more containers. So this is basically what a container app environment and container apps look like in a cloud environment. Now, let's go and dig into the Azure portal, see what the services look like in Azure. So I have a couple of resource groups, and these resource groups all form the polling application that you all used to cast votes on my questions at the beginning of these sessions. And for the remainder of this session, I would like to show the entire container app environment and the container apps, how I created this environment, and how I deploy the environment into a production ready environment. I will zoom in a little bit. And this Polestar integration production North Europe ENV is my container app environment. And when I scroll through this environment, you can see that it already comes with Dapper components that I configure. Again, I will handle Dapper in a bit. It contains certificates, so you can upload your certificates in one central environment before you use it. You can use custom DNS. So this is for, wait, this is new. I didn't see this. All right, so you have DNS suffixes. I think this is for custom domains. And then obviously you have your apps, and these are all the container apps that live in this environment. Now, it is important to understand that when you create an environment, you are going to have to choose a certain virtual network that that environment lives in. And if you don't choose a virtual network, then the container app environment will create one for you. So there's an advantage here, because in the previous session, you saw that a virtual network is important for protecting your services from the big mad internet world on the other side. So when you want to protect your services, then a virtual network is the first step. And with container apps and with a container app environment, that first step will be taken for you. So again, you can bring your own virtual network and tell the container app environment to integrate in that virtual network. And if you don't, then the container app environment will create a network for you and run that under the hood. So you don't have to control that network services if you don't like to, because the environment will do that for you. So now if we dig into container apps themselves, now we have seen the environment. There are also container apps that live in that environment. And maybe you want these services to be available for the outside, for the public internet. And there's a setting called ingress that you can use to configure how your service must be available for the public internet. And there are two flavors here. One is limited to the container app environment. So this is, again, if you don't provision your own VNet and have the container app environment do that for you, then if you choose this setting, services can communicate with each other within the container app environment, but not services from outside the internet cannot reach your container app. Then there's a setting limited to your VNet. That means basically the same, but then in your own VNet. So every service inside your VNet can access the container app, but everything outside the VNet cannot. So the service won't be available for the public internet. And the third option is from anywhere. That basically means the public internet, everyone on the public internet can reach your container. Each and every container app has a property called secrets. And you can compare the secrets to key vault secrets, but you should not rely that heavily on the secrets of a container app, because you don't have that much control over who can access those secrets, who can set those secrets and whatnot. If you really want to use secrets, and again, in the previous session, you saw that there's a thing called managed identities. So please use managed identities or user-assigned identities to connect to different services, but sometimes you simply cannot go around secrets. So if you really want to use secrets and you want to use secrets in a production environment, then still I think it's a good idea to use the Azure Key Vault instead of using secrets in container apps. But also in this case, sometimes you need to use secrets of a container app. So please know that if you want to use a secret, you don't have an Azure Key Vault available, then this is the way. This is the way to store secrets. So don't use any text or something. Changing secrets can be done on the fly. It doesn't affect the running environment. It doesn't start a new instance, for example. So it will not impact any existing running revisions in your production environment. Now Dapper. Dapper is huge and amazing. Dapper is an abbreviation for distributed application runtime, and it runs as a sidecar. So as a developer, you don't really have to know what happens under the hood, because the technology of Dapper will attach to your system. And it will understand what your system needs to do, and it will handle accordingly. And it's really magic. So there are a couple of components that you can use, a couple of Dapper components that you can use in container apps. For example, caching, this messaging mechanism, storage, but also intercommunication between the services that live in your container app environment. And Dapper will take care of the resilience. So for example, if you want to communicate from one service to a different service, and the initial request fails for whatever reason, then Dapper will take care of retry mechanisms and the service breakers and whatnot. So you don't have to do that all manual. Then there's KIDA, because container apps under the hood run Kubernetes. There are very sophisticated ways of scaling your container apps in your cloud environment. And KIDA comes out of the box, and KIDA stands for Kubernetes Event-Driven Autoscaling. Now, what is that? I already mentioned, if you have a microservices environment and you want these services to communicate with each other, one way is to, for example, use Dapper and make a direct call to a different service. But that would make one service dependent on a different service. And sometimes you simply don't want that. Sometimes you have a certain process and you want to distribute that process and make that happen in the cloud. And once the process is done, then you get back to the user and say, hey, I did, for example, an import process or whatnot. I am done. And when you want to create that, then a messaging mechanism, for example, the service bus or event grid, are good tools to use in your Azure environment. But now let's assume that a lot of messages come in, for example, on the service bus queue that you need to handle, and your service cannot handle that. Then you want to scale your service out. And this is exactly what KIDA does for you. So you can configure KIDA to monitor, for example, a certain queue in a service bus or a topic or event grid topics. And it will recognize the work to be done on those queues, and it will scale the service out to multiple replicas. And when all the work is done, it will scale these services back in, making sure that you don't pay too much money for a scaled out environment. So it's really flexible. Now, there are two ways of scaling your system when you run container apps. The first one is KIDA, and the second one is HTTP traffic, because KIDA doesn't monitor HTTP traffic. So if you have a service that accepts HTTP calls, you can also configure your container app to scale depending on the amount of requests that come in. Now let's dig into the Azure portal again and see what the container apps look like in the environment. So what you saw is this polling application that you guys all casted votes on in the beginning of this session, that in the basis contains of 4 different services. One service is a user service, and the user service is used to identify each and every one as an individual person. So once you hit the website, the front end will make a request to the backend, and that is the user service. It will generate a GUID, so it can identify you as an individual. Then there are three different services. One is a session service, and the session is, in this case, the entire virtual Azure Community Day session for this Polestar application. And in that session, I can configure multiple questions. So I fired two poll questions to you. One is the container technology question, and one is the have you ever used container session. So basically, in a session, I can group multiple polls. So one service is the session service. Now there's a poll service, and in this poll service, I can configure questions and possible answer options. And the fourth and last service is the vote service, and the vote service consists of a container app that accepts votes and a function app that will process votes in the background. And then in the end, there's one reverse proxy that will accept all incoming traffic and redirect the traffic to the corresponding service. So, for example, let's dig into the poll service. This is a container app that lives in the Polestar integration production North Europe environment. So that is the container app environment that I already showed you earlier. So all these services that you just saw live in the same environment. Now there's a couple of properties here. You can see that this one already exposes a URL, but if I follow that URL, you will see that it is not available. And that is because the ingress is set to only accept traffic from inside the container app environment. This is the secrets tab that, and with the secrets that I already told about. And as you can see, I don't use any secrets because secrets are evil. So if you don't have to use secrets, don't use secrets. And if you do, then please use the key vault. And if you really cannot use the key vault, then use secrets here. But for most of the services, managed identities are available, so please use managed identities or user-assigned identities if you can. Then this ingress, this is where you decide what type of traffic you want to accept. And in this case, I do accept HTTP traffic, so the ingress is enabled here. And as you can see, ingress traffic is limited to the container app environment. So this service accepts traffic, HTTP traffic, and it will redirect HTTP traffic to port 80. And this is the port that on my container that is exposed. So it will accept HTTP traffic, and it will redirect the HTTP traffic to the container that lives inside this container app. But again, it only accepts traffic from the container app environment. Now, there is a setting for continuous deployment. You can hook container apps up with GitHub if you like, and then GitHub will fire an action, and from there you can automatically deploy any changes to your container app environment. I do this, but manually, and I will show you how I created the GitHub actions together with infrastructure as code. To deploy this entire environment. Now, custom domains, obviously, you want some services to be exposed to the public internet. And with the custom domains, you can give them a nice name and hook your own domain on it if you like. Now, with Dapper, you can leverage the components that come with Dapper inside these container apps. Now, I don't use any special components for this service, but I do have Dapper enabled, because if you have Dapper enabled, you already leverage the ability to communicate from one service to another. And Dapper uses the service discovery in Kubernetes to make sure that you target the correct service. So the only thing that you have to do is make a call to a certain app by name. And as you can see here, this app ID, in this case, the ID of this application is Polestar-Pols-API. So from within my container app environment, I can use Dapper to make a call to HTTP and then the name of the service and then a certain port, in this case port 80, and then Dapper will make sure that that HTTP request will end up on this specific service. And in this case, I do accept HTTP traffic. You could also go for gRPC if you like, if you want, for example, binary data. Then this gRPC may come in handy. And a couple of buffer settings, but I'm going to skip those for now. Then there's identity, and this identity is a managed identity. You can turn it on and make sure that this service appears as an identity in your Active Directory, so you can give it permissions or grant certain roles to it, so it is capable of accessing resources that you like. And I use this because in my central environment, I have Azure, the Azure Configuration Service and Azure Key Vault that contains all the configuration for my containers, and I need to access those services, and I use this managed identity to make sure that I use this identity as for role-based access to make sure that I can access those services. All right, and finally, there's revision management. So there are two different strategies if you want to roll out new revisions. One is single, so all my services in this environment are set to single, and the second one is multiple. And the difference is that with single, there is only one revision active at a time, and with multiple, you can have multiple revisions at a time. And what you see in the background here is this grayed out traffic. It says the current active revision receives 100% of the traffic. And what you can do is create a new revision. If you have the revision mode set to multiple, create a new revision and then change the percentage of traffic that ends up in the first service and the percentage of traffic that ends up in the second service. If you have an HTTP endpoint ingress enabled for your application, you can also use this label and then target a specific revision because this label will end up in the name of the URL of the revision. So then there's containers. Again, a container is a piece of software, and the piece of software needs to be it's an image. So and this image needs to be stored somewhere, and somewhere in a public place that this service can fetch the image from. So in this case, I use the Azure Container Registry. And in my pipeline, I will build and compile the container. So then I end up with the container image, and I will upload that container image to this registry. And I will tell the container app that it needs to pull the image from a Azure Container registry, and then this specific registry, and then I tell, okay, this is the name of the image that you need to pull, and this is the version of the image that you need to pull. Then with environment variables, you can configure your container. And there's not really much to see here because all my configuration is handled by the Azure Configuration Service. So the only thing that that my environment variables contain is the link to the Azure App Configuration Service and the name of a local storage account that I need to store data in. And again, this storage account is accessed through managed identities. Now back to the scaling rules. I already explained that there are two different ways of scaling your application. One is HTTP traffic and one is SCADA. Now this service is a HTTP service, so I have a HTTP rule configured, basically stating that if there are more than 30 requests per second, then you need to scale up one replica. If I go back to my container app environment and then apps, and then this votes from container app, this is again a container app that lives in the same container app environment, but this is an Azure function. And this Azure function has a function that is triggered by a message on a service bus queue. So this service can be scaled with Kida. Now, if I go to the same scale tab, I see a event-driven rule right here. And with this event-driven rule, I can say, okay, I want to scale in a custom way. This is the connection to my service bus queue. And I want to scale up if the amount of messages on the votes queue exceeds 20. So if there are more than 20 messages on the votes queue, the service will scale up and deploy a new replica. And if the amount of messages then drops again, it will scale the service back in. All right, so now you have seen the entire environment. This is a visual representation of the environment. So again, there all the way on the top right, there's this user app, a sessions app on the below that, then a polls app and a votes app all the way on the bottom. Those are the four services that I need to host the poll environment. But then I thought it was a good idea to have a gateway app, which is basically a reverse proxy to handle all the incoming HTTP traffic and redirect that traffic to the service accordingly. And that is where I use Dapper. So I want to show what I did, and this is a Node application, and I didn't know Node before, so this was a nice. Oh, this is the wrong service. Oh, hold on. This was a nice experiment for me. I used GitHub Copilot for most parts of the creation of this service, because again, I didn't know any Node. Reverse proxy. Oops, sorry. Yeah, there we go. So this Node app, in my container and app environment, I expose this Node app to the public internet. So this service accepts requests from the public internet, and you see that I have a couple of routes configured, and each and every service that I want to target in my container app environment is represented by a certain route. So let's, for example, go to the sessions route, and that basically means that everything that every request that ends up to my service/sessions will be handled by this service, and you will see that it redirects the traffic to a certain target URL. But this target URL says, hey, you need to target the Dapper sidecar. Now let's go ahead and investigate what this Dapper sidecar does, and I will zoom in a little bit. On line 9, you will see that it will target localhost and then a certain port. And the default of this port is 80. And it will also target a certain service name. And the default of this service is Polestar Session API, but it's, in the end, the name of the service is configured by configuration. This is the name of the Dapper application ID. And this is the port that we target. So what happens is right here, I will redirect the traffic to a certain service, and I will add a header. You need to target an application with a certain depper ID, and this is the name of the depper application ID. And what happens if you run this, for example, on your local host? It will go. Your request will end up on localhost and then port 80. If you run this in a container app environment with Dapper enabled, then Dapper will kick in and will see, hey, you want to target a certain Dapper application ID. I will go ahead and use service discovery to see if I can find this service in your container app environment, and I will target that service instead. So this is really magic. You can use so again, if I go to my container app environment and then to the Dapper tab, so this means that you can use this poll start votes function name to redirect traffic to this specific function. And that is all that happens in this reverse proxy. The only thing that I do is use service names of services that live in my container app environment to target the services from the reverse proxy. All right, next up, I want to show how I deploy the entire environment in Azure. And to do so, I think it's important to have a different project that lives completely separated from all the applications. And this different project is a infrastructure as code project, and I use Bicep for infrastructure as code. And this will deploy my entire. I call this an integration environment. So this will deploy my container app environment, so it's ready to receive all the containers that I want to host in that environment. And as you can see, there are a couple of parameters, and I'm going to skip those. I'm going to go ahead and dig into the integration, because this is where the magic happens. So all the way on the top, this is my container registry, and this is where the containers end up once the build process for a certain container is done. So this entire project is hosted in GitHub, and I use GitHub Actions as a CI/CD mechanism. And in GitHub Actions, I will go ahead and compile my system and create a container image. And then I will upload the container image to this container registry. The only thing that I have to do the only thing that I have to do when that is done to deploy the application is to tell the service there is a new version of this container. Go ahead and grab that container image and run it. Then there's this Azure App Configuration service that I need to be able to configure all my services. And obviously, all the way on the end, I use Log Analytics and Application Insights. You can hook Application Insights into your container app environment. So when something went wrong in your container app environment, you can go ahead and look into Application Insights or in your Log Analytics workspace to find what's going on. So that's a really nice way of handling errors. And obviously, each and every container hooks into the same application insights, so I can log and send metrics to that environment if I like. Now, this one is very important. This is the deployment of the container app environment itself through infrastructure as code. So it's fairly simple. You give it a name, and then all you have to do is make sure that this Log Analytics workspace is attached to your environment. Now I use Azure Web PubSub to make sure that I can handle real-time traffic for the polling mechanism. There are a couple of secrets here. Well, this is basically all configuration values that end up in the Azure configuration service. So, for example, there's a service bus for handling votes. And if services want to connect to this service bus, then they need to have the name of the service bus, and this name of the service bus is configured in Azure App Configuration so that all the services can access it. Now, if we dig into a certain application, so this is the integration environment. Now let's dig into a container app itself, for example, the Votes API. This one hooks into the environment, and as I already mentioned, I use GitHub Actions to deploy everything. So the first job that happens in the GitHub action is this versionize job. I use semantic versioning for versioning my systems because I think it's really nice to have control over the next version of my system and make the version number predictable. And this is where the magic happens. So I will log into to my Docker container, to my container registry in Azure. I will build the containers, and the version of the container comes from this versionize step. So it needs the versionize step, and the output of this versionize step is the new version of my container. And I also built a container with the version latest. And both of them are uploaded to the container registry. This is, I'm going to skip this part because this one is specific for the function, which is basically the same. It builds up a container with the name function. This is the function app that handles all the votes. And now this publish bicep, this is actually publishing my container app environment using bicep in my production environment. So what happens? It will. Oh no, sorry. This is the publish bicep. Sorry. Need to skip to this one. This is where I deploy my environment to my production environment. So I log into Azure, and then I deploy infrastructure as code using this command. So that is AZ deployment to a subscription, create a new deployment, and then name that deployment on a specific location. And now the deployment itself is also handled in using infrastructure as code. And that is this function app. No, this is again, that is this container app. So this container app tells infrastructure as code, so the Azure Resource Manager, to create a container app in my already existing container app environment, and then go ahead and download a container image from my container registry, and then the newest, the latest version. So what happens if this container app already exists? Now there is one small problem with container apps that currently exists if you run the revision in a single mode, and that is that you're currently running revision will go down. Your new container image is downloaded before it starts. So you have some small downtime there. And I know that the team is currently working hard on it to get rid of that downtime. So be advised, if you run this revision mode in single, then you have some downtimes if you deploy in this way. If you have if you use the multiple strategy, you can already deploy the new revision next to your currently active revision, and then transfer the traffic from one revision to the other, and that will reduce the downtime. So one important thing is that here in this template, you see this container section, and this container section contains a resources. And this is the resources that you actually use to run your container. And it consists of a certain amount of CPU and a certain amount of memory. And this is what you pay for. So if you want to have a heavier, if you want to host your container on a heavier resources environment, so more CPU, more memory, you obviously pay more. Now, the advantage of a container app environment is this scaling part. You can scale your environment and each and every container all the way down to 0. And if you have 0 containers running, then you pay 0. But you have to keep in mind, for especially with HTTP with containers that accept HTTP traffic is that you have some startup time. So if you have a service that runs that accepts HTTP traffic and is scaled back all the way to 0, and a request comes in, then it takes up to 10 seconds for the container to start up and process your request. So sometimes it's not that smart to scale back all the way to 0. On the other hand, if you have background processes that handle messages on a queue, for example, that people don't necessarily want a request for at that time, then for those services, it's a good idea to scale back all the way to 0, because if they're not doing anything, you don't pay anything. And as soon as a message comes in, then SCADA will make sure that the service is alive. It will process the message and scale back again when nothing is to be done. So with that, I want to conclude my presentation, and again with this link. This link, well, you can also scan the QR code, by the way. This link will bring you to my GitHub repository with a search query that will bring you to all the repositories that I use to create this entire solution. And then again, thank you for your time. Thank you for listening. Thank you for joining the virtual Azure Community Day. And make sure to reach out to the organizers and thank them, because they put in a lot of effort to get this conference done for you. So yeah, let's go.
Thank you so much. That was a delightful presentation, and it brought so much more clarity into is this another black box solution? How flexible is it? Can I use it in production? I think that we can see already that there is a very good use case for this, but how to determine if you're starting now a new project? What are you gonna do? Are you gonna use AKS, or are you gonna use container apps? What would you advise?
Well, the story is that if you're already familiar with AKS, then the bridge to AKS is probably not that difficult to take. On the other hand, if you're not really familiar with a container environment, then the Azure Container App service is the service to go, because it's fairly simple to understand. There's not a lot of complicated wheels and knobs that you need to twist and tweak to get your environment up and running and to keep it up and running. And both services under the hood run Kubernetes. So if you end up in the situation that you run with Azure Container Apps and you hit the limits of Azure Container Apps and come to the conclusion that you still need the AKS service, then you can, because they still run the same environment under the hood, and you can migrate one environment to the other.
Is there an easy way to do that migration, or is it more manual labor?
At this time, it's manual labor. I asked the question to the team, is this going to be a button that you can, okay, bring me to AKS? The answer was not yet. So I think that's promising, but yeah, I'm not sure if this button is going to be there, but that would be really powerful.
We want that button.
Yeah,
that would be so cool to have a button, like because it kind of makes sense. Your company is growing, your knowledge is growing, you're getting more into the containerization, but at some point, and I think that the talk after this one will dive more into it, but sometimes you just need that extra functionality and the customization of the behaviors of your application infrastructure. So it would be really good if people could like ease into that, but it's already doable with some manual.
With some manual labor and put some effort in it, and you can get it done, because in the end it's containers, and you can grab one container, pull out the plug, bring it somewhere else, plug it in, and it will run.
Is this the is ACI still, Azure Container Instances, still useful?
Yeah, but the problem with Azure Container Instances is the scaling capabilities. So if you end up in a situation that you need to scale out, then you run into problems with ACI. So yeah, it is a thing. it still is a thing, because this one is all the way on the left in the spectrum of the beginning of my session. So it's one of the easiest way to run containers, because you can just throw a container at it, tell it to run the container, and it will run it for you. But it has some limitations.
Awesome. Thank you so much. If you want to learn more about it, scan the QR code, or otherwise we'll put the link in the chat. Thank you so much for being here.
Yeah, it was fun.
In our little studio. It was good having you, and well, hope to see you around.
Yeah, hope so too.
Thank you.
Bye.
And of course, stick around while we make some adjustments to the studio for our next speakers, and we'll be back in a few minutes.